So what happens though if I'm not just doing a state change and instead I'm also changing temperature? Well, then we're going to have to go back to the concept of specific heat, which we've already talked about. So what I require for these problems when they're multi-step problems, I require you to explain what's going on, actually verbalize what's going on as you do the math, okay? Really quickly, as an aside, if you notice, just to reinforce the fact that more heat is required to vaporize versus melt, if you notice the heat of fusion for water is only 6.02, while the heat of vaporization is 40.7. And that's simply because you're breaking all of the intermolecular forces between a liquid and a gas, while for a solid and a liquid, you're not breaking all of them. Okay, so this question asks you to calculate the total heat in joules needed to convert 25.0 grams of ice at 0 degrees Celsius to a liquid at 25 degrees Celsius. So I'm starting as a solid at 0, so that's right at the beginning of the first plateau. I'm going to move across that plateau to become a liquid, so I've got to melt it, and then it has to go from 0 degrees Celsius up to 25 degrees Celsius. So this is going to be a two-step problem. So the first step is going to be going from a solid to a liquid. All right. So since I've got 25 grams, what I can do to determine the heat required for that state change is I can use my heat of fusion. So I'm going to go from grams of water into moles of water, and then for moles of water I can get into kilojoules, and that will give me my heat that is required in order to melt that substance. Then for step 2, I'm going to go from a liquid at 0 degrees to a liquid at 25. So I'm going to be using my specific heat, which in your book shows up as SH. We learned it as C. Okay? So Q equals MC delta T, that should look familiar. I'm solving for Q here. So my Q equals the mass, which is 25.0 grams, times the specific heat. Notice the specific heat of a liquid and a solid are different. I'm using the specific heat of a liquid, which is 4.184. Then I'm going to multiply that by the change in temperature. Remember, change in temperature is T final minus T initial, so 25 minus 0, because I finish at 25. And I get my heat, which is 2,620 joules. In order to add these together, I've got to convert one of them into the other unit, so I'm going to convert into kilojoules. And then to find the total heat, all I have to do is add those together. Now notice the question asks you for joules. So instead of 10.97 kilojoules, this would be 10,970 joules for your final answer. So for these problems, guys, if you know for the steps that I actually wrote out, I wrote step 1, solid to a liquid. You have to write these out so I know that you know what's going on.